Hello dear students, since the exam is just day after tomorrow, I have brought you one more video of important points. Chapter 6 Electrolysis. I would try to post one or two more. So what is electrolysis? Electrolysis is electricity breaking down of ionic molecules in respective ions. So this is the electrolytic cell looks like. This might be a glass container or silica container. Now here there is either molten electrolyte or an aqueous solution of electrolyte. Why molten or aqueous solution? Because solid ionic compounds, even though they are ionic compounds, they consist of ions, they cannot conduct electricity because ions are fixed. Okay, they are bonded and they cannot move. Two things are must for flow of electricity. Number one, there should be charge. Number two is charge should flow. If charge is there and it's not flowing, electricity cannot flow. If charge is not there, electricity cannot flow. When you are having molten form or aqueous form, ions are there and they are free. Okay, so here you have two metal rods. One is charged negative, another is charged positive. Negative charged rod is called cathode, while positive charged rod is called anode. On cathode, during electrolysis process, metal deposits, positive ions come and they deposit. Generally gas is released on anode. Okay, so this is the basic of all the electrolytic reactions that we are going to study in this chapter. Just learn it well and you would be able to make the ions, and then you can predict where the ions will go and what are the compounds they are going to give at anode and cathode. This is as simple as this. Now, electrolytes are of two types. Strong ionic compounds are strong electrolytes, and polar compounds or organic compounds are weak electrolytes. Strong electrolytes examples: lead bromide, sodium hydroxide, HCl, while weak electrolytes acetic acid, ammonium hydroxide. You have to keep in mind, see, when it is molten, you can see in this only sodium and chloride ions will be formed. So only one type of cations and one type of anions would be formed in molten form. But in aqueous, see, water is also there along with the electrolyte. Water is also there. So you would have two types of cations and two types of anions at least. Okay. Now when this happens, then there is competition between two or more cations to reach to cathode and deposit there, and competition between two or more anions to reach anode and deposit there or release there. Okay, now which one would go first? In this case, in aqueous solution, which one would get deposited depends upon position of metal or non-metal in the electrochemical series. The electrochemical series gives a good idea of reactivity of metals and non-metals. The ones which are least reactive will get deposited first. Okay, so you have learned electrochemical series earlier in class 9. Just go through it once more. Go through the electrochemical series of negative ions as well, and you would be able to learn and figure it out that which ion is going to deposit on cathode and which ion is going to release as gas. Next important points to be remembered are whether the electrodes are inert electrodes, for example graphite electrodes or platinum electrodes, or they are active electrodes like copper electrodes. If they are inert electrodes, and for example in the book there is example of aqueous copper sulfate aqueous, there would be two cations and two anions. Inert electrodes mean they do not participate in the chemical reaction. Only electrolyte and the solvent are undergoing the electrolysis and are the reason for the result on cathode and anode. So when aqueous solution is taken, copper sulfate is going to divide into copper ions and sulfate ions, and water is going to divide into H plus and OH minus ions. Copper ions and H plus ions will compete for cathode. Sulfate ions and hydroxide ions will compete for anode. Copper ions, they are less reactive than hydrogen ions, and therefore they would deposit as copper metal on cathode, while hydroxide ions, they are less reactive than sulfate, and therefore they will go to anode and will release as oxygen gas. This is the reaction that you have to follow. Okay. Now if the electrodes are also reactive, if the electrodes are active, They are also going to participate in the electrolysis reaction. Okay, so what is going to happen at anode when anode is reactive? See, copper anode is going to release copper ions. Okay, so here there is no release of any negative ion. There is no release of any gas. And at cathode you have copper ions deposited as usual. Okay, so see the difference between the two. Here you are going to see that copper is going to deposit at cathode while oxygen is liberating at anode. In this, at anode, copper is releasing as copper ions. There is no deposition, there is no release, while at cathode there is deposition of copper metal. So this reaction is same, but this reaction is different. Now in this one where you have inert electrodes, blue color fades, while in this one where you have active copper electrodes, blue color does not fade, it remains, because copper ions are coming into the solution. Okay, and sulfate ions are not going anywhere, so copper ions are also there, sulfate ions are also there in the solution, therefore blue color does not fade away. This last reaction, in which at anode metal atoms are changing into metal ions, and at cathode metal ions are changing into metal. So what is happening here? You can see that movement of metal ions from anode to cathode is the reaction, is the resultant reaction that is taking place. So this is very useful reaction. This is used in electroplating. This is the basis of electroplating and electrorefining, three of which are given in the book, and you would see so much similarity when you understand this fundamental. Okay, oxidation is taking place at anode and reduction at cathode throughout in all the electrochemical reactions. Thank you so much for watching. I wish all the best to you for the examination. Thank you.